Hello everyone, welcome to you all. This is Preetham and today we are going to learn confusion matrix. So first of all, this is a disclaimer. Do not just carry it away with the screen that is in front of you right now. We will discuss one by one. Okay, so let's get started with trying to understand what is confusion matrix and why it is needed. Okay, so as the name says, confusion matrix. Yes, it is a matrix, but let me tell you, it is not at all confusing. We'll keep it as simple as possible. Okay, so let me channelize you all through this way. Like in general, just recall your thoughts. Whenever we come across the words like prediction, automation kind of words, like we all get excited, and today's machine learning models have literally turned them into a reality, right? So now imagine you have a machine learning model with you and you have some requirement to predict something. You have the data set as well, that one is to be predicted. Now you run the model, you got some output, but the bigger problem comes here, like how efficient or how accurate, how correct your result is, the model evaluation, right? And the confusion matrix comes into the picture here. Like it helps us to compare the models, to evaluate the models, to choose the model, to choose the best model out of it, right? So for your better understanding, I have taken a cancer diagnosis report data set of some 20 patients. So as you can see the data set here, there are 3 columns. First one is patient ID, like 1, 2, 3, 4 up to 20. And the second column is the actual report, that is the cancer report, actual report that is given by the concerned doctor. And the third column is the predicted report, that it is the machine generated report. And those report have only 2 categorical values, that is positive and negative. So let me read you the data for you. Like for example, the patient ID 1 has the report, actual report says negative, and machine has also predicted as negative. And likewise for the, if you see the 4th patient ID 4, it is actual report says positive, but the machine says negative. So we will try to create the confusion matrix. We'll build the confusion matrix on this particular data set. So as we have discussed, confusion matrix, this is a matrix. So it has 2 rows and 2 columns. It's a 2 cross 2 matrix of order 2. So I have taken here in the rows, I have taken actual report of positive and negative, and in the columns I have taken predicted reports, positive and negative. So here I'll be filling the count of all those positive and negative combinations. So here, as you can see, there are some notations, T and FP, TP and FP. So let me read out this notation for you, it will be easy. So here is the report. TP means true positive. True positive means the machine has truly predicted as positive. You can see here, like it is marked in darker green one. The prediction is positive, like by the machine, and the actual report is also positive. So this is a true positive case, since the machine has truly predicted as positive. Likewise, false positive means machine has falsely predicted as positive. False positive, the darker red one, machine has positive, but the actual report as negative. So it is falsely predicted as positive. Likewise, Fn and Tn, false negative, falsely predicted as negative, and truly predicted as negative one. So we'll fill this up, these values here, positive and positive, predicted positive and actual positive. How many predicted positive means truly predicted as positive TP values? How many TPs are there? 1, 2, 3, 4, 5. Okay, so there are 5 TPs here. That means truly predicted as positive. This one is for negative prediction and actual positive. That means falsely predicted as negative, falsely predicted as negative, falsely predicted as negative means Fn. How many Fn's are there? 1 and 2. Okay, this one is prediction positive but actual negative. Prediction positive means this is actual negative, so falsely predicted as positive, falsely predicted as positive. FP, FP, how many FPs here? 1, 2, 3, 4, 5. So there are 5 FPs. The last one is both negative, actual negative and predicted negative. That means true negative, truly predicted as negative. How many such cases? 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so if you sum up all these values, this will be 20. That is the total count of patient. Okay, so this is done. Confusion matrix is created now. Now the confusion matrix is created, but what to do with it? How to evaluate? How to choose the model? So there are some 4 types of evaluation matrices that are precision, recall, accuracy and F1 score. These matrices helps us to choose the best model. Based on these values, we choose our best model. Okay, what the formula says, the definition says precision TP divided by PP. PP means predicted positive, that is total positive of prediction, TP plus FP, that is predicted positive. PN means predicted negative, Fn plus Tn. Okay, AP means actual positive, AN means actual negative. Okay, so as the formula says, TP divided by PP, that means truly predicted as positive divided by total predicted positive, total predicted positive. So TP is here 5. So we'll calculate all this equal to TP. TP is what? This is TP divided by PP. PP means this. PP means TP plus this is FP. Enter 0.5. So if you convert it into percentage, it will be 50%. So the precision is 50%. Correct. Likewise, we can calculate the rest of the matrices, evaluation matrices. Recall is TP divided by AP. That means TP is 5 divided by AP. AP is actual positive. That means actual positive is TP plus Fn 0.71. So if you convert it into percentage, 71% is called. It is the recall of the model. Accuracy is the TP plus Tn. That is TP. It is TP. This is Tn. Truly predicted as positive plus truly predicted as negative divided by AP plus AN. AP plus AN. This is actual positive plus actual negative. This is nothing but the total data points. Okay, so let's calculate this. TP plus TN, this is TP plus this is TN, okay, divided by total is 20. So enter, this is 65% accuracy. And the F1 score, this is nothing but the combination, not exactly combination, actually this is the harmonic mean of precision and recall. Okay, so equal to this is the direct formula to it, 2 multiplied by precision multiplied by recall divided by precision plus recall, precision plus recall, 0.59. So this is the 59% F1 score. Okay, all these are evaluation matrices. And let me tell you, like here I have mentioned FP as overestimation type 1 error and FN is underestimation type 2 error. What does it mean, overestimation or underestimation? Like FN is like FP is what? FP means false positive, that means falsely predicted as positive. So the machine has predicted as positive, but it is false, it is actually negative. So imagine now you have like someone has cancer whose actual report says negative, but the machine predict it as positive. So it is a kind of concern, but nothing serious around it, right? Because you do not have cancer, the machine falsely predicting as positive, right? So it is an overestimation. This in statistical term we call it type 1 error. Okay, but in case of FN means falsely predicted as negative. Here, if you see here, machine has predicted as negative, but actually it is positive. Now imagine someone has actually cancer, but due to machine, machine has given him report as negative. He might be neglecting that, how severe it is. So it is comes under the underestimation. In statistical term, we call it type 2 error. So the type 1 error is like you can ignore that, but type 2 error is like very important to address it. Okay, so I hope you all understood this, and thank you so much for attending.